Hi, my name is John Drake, and I'm an assistant professor in the Sustainable Resources Management Department at SUNY ESF. And this video is meant to introduce students to a sugar bush at Heiberg Forest on land owned by SUNY ESF. And this is meant to introduce students to some of the structural elements of the forests of sugar bushes, and particularly the open nature of sugar bush grounds, and some of the other aspects in the way these stands are managed and tapped for maple syrup production. This video is meant to complement another video that describes the tapping and the sap processing procedure more extensively, and a set of data analyses that students at ESF are expected to do. Hope you enjoy.
So this is one of the distribution pipes here in the sugar bush, so that many tapped trees, the sap is collected in particularly this tube in front of me, this lower one, and this lower tube is then drains into a central collection house that you can see in the distance behind me. So both of these tubes are exposed to a vacuum pump that helps pull the sap out of the trees, and the liquid sap will run towards the collection house through this bottom tube. The larger tube above is not designed for liquid sap to move through it, but the larger tube above is designed to help the vacuum pull air out of the system, such that if there's air bubbles in the water distribution lines, those air bubbles can move up into this higher line, and we can have a continuous flow of liquid in the lower tube. So this vertical piece here that connects these two pipes allows for the air bubbles that might be in this pipe that's designed for the liquid to flow to be sucked up and moved into this upper vacuum distribution pipe, such that the liquid comes in and continues draining down this lower pipe to the collection house. So this sugar maple is a large, healthy tree with a nice big spreading crown, and large trees like this can support multiple taps. So you can see this tree has been tapped at 2 locations, and it's tapped at new locations each year. So there is a size determinant of how many taps can be safely supported. So here are 2 sugar maple trees that are tapped, that are being used for the collection of maple sap. Neither of them are particularly good form if you were interested in producing maple wood, given this multiple stemmed tree. But you can see that there is a tap here on the tree to your left that it was installed early in this winter, and there's also a tap on this tree to your right that was installed at the same time. And so the sap is being collected from both of these trees as part of this sugar bush operation. So this part of the sugar bush has a canopy that's dominated by relatively large sugar maple trees, like this one in front of me, and very little of a substantial understory of other hardwood trees, other than these brambles and hobblebush. So this is an example of the wide open spreading crown structure of a sugar maple tree that is desirable in a sugar bush standpoint. So this crown isn't perfectly symmetrical. There's more branches to the right than the left, but the crown is wider and more spreading and more open than is typical in a more closed canopy forest that's often present in northern hardwood systems. So we've moved up the hill to a portion of the upper sugar bush, which has been thinned more extensively, managed to have a lower residual density of the remaining sugar maple trees. And if we look above us, we can see a more open canopy structure. There's more open space in between each sugar maple crown. And that allows each sugar maple tree to have a nice big broad spreading crown, but presents a potential problem in terms of working in this stand because of all of the light that's let through that open crown structure in between the trees. We have more extensive growth of kind of some undesirable things in the understory that present a challenge to kind of moving through this Sugarbush to do work like maintaining the lines and tapping the trees. So this relatively large sugar maple tree in the distance has a nice big spreading crown that's very wide and deep that allows it to access a large amount of light to generate a lot of sugar. The canopy of this sugarbush is relatively open, such that each individual sugar maple tree that is being tapped is able to have a large and spreading crown. In general, sugar bushes are managed such that evergreen trees are removed from the stands. This evergreen in front of me, because it keeps its leaves, it shades the understory and shades the tap lines that go beneath it, and thus prevent those lines from warming up on warm spring mornings. And thus these conifers or these evergreen trees generally inhibit sap flow in these systems and tend to be removed, but this one was kept. The management of sugar bushes clearly emphasizes the establishment and healthy growth of sugar maple trees, which produce the most sap. But there are often remnant trees of other species that are left behind as a component of the system. So behind me you can see this yellow birch tree that was left and is not tapped, but provides some more general benefits to this stand by providing diversity in the trees that are present in this stand, which has lots of benefits, including the minimization of pest outbreaks and other things. One of the challenges in this particular sugar bush is that there have been several outbreaks of forest tent caterpillar in these stands that have defoliated the canopies. And the thought is that if this forest was more diverse, had more different kinds of tree species in the canopy, there would be fewer outbreaks like that.
So I hope that glimpse into what a maple sugar bush looks like was interesting and informative. I hope you saw some evidence of management decisions of how many trees that aren't sugar maple are kept and retained in the system, how open the crowns are managed to be to increase the light that's acquired by each individual sugar maple, potentially at the expense of forest undergrowth that's undesirable. There's also decisions being made as to how many taps to tap each tree as a function of their size. And the location of this sugar bush was also chosen in part because of the high density of sugar maple trees, but also the topography of the system allows the use of gravity to help drain the lines. So if you're an ESF student in my Natural Resources Ecology class, thank you for watching this video. You need to also watch the other tapping video and do the data analysis exercise. Thank you.